we will just jump right in. I'm going to quickly introduce our panelists here, and we have some interesting news that we will. You will be the first to hear today. I don't want to steal the thunder. So first up will be Roger Melko. He's a professor at the University of Waterloo. And hold on.
The Perimeter Institute for Theoretical Physics.
Actually, I'm going to just be very quick in names, titles, organization, but I'll let each panelist give a little bit more background, because I will not be able to do them justice, and then we'll go from there. So Roger, and then after Roger will be Zeng. Dr. Zvonimir Bandic. He is the open source advocate at Open Quantum Design. And last but not least, Zeng, partner at Quantonation. So without further ado, Roger.
Thanks, Rima. Yeah, I'll to maybe elaborate on the introduction point. So I'm an academic. I'm a professor at the University of Waterloo and Perimeter Institute. I'm also the the scientific director of the Creative Destruction Lab's Quantum Stream. I think many companies at this conference have gone through CDL's mentorship program based out of Toronto Rotman School. We've had 150 companies interact with us since 2017, which is when the Quantum Stream launched. Those companies, the ones we mentored, have gone on to raise over $700 million after they've left our mentorship program. Just to talk long here, our late great founding academic director, Peter Witek, was a huge open source advocate. And so in many open source projects, and some of you might have known Peter Witek before he died. And so I in some sense, being part of this open source community for me is very much continuing Peter Witek's legacy. But one thing that I've never been to Q2B before, and everyone's like, Roger, what are you doing here? Well, I think the most exciting thing for me right now is that we're here launching our own open source initiative, which is called Open Quantum Design. And Greg Dick, the CEO, is in the audience. I can't see anything. There he is. But Open Quantum Design is a full stack open quantum computer that we're launching out of the Institute for Quantum Computing and the Perimeter Institute for Theoretical Physics in Waterloo. And it's a very exciting, open full stack quantum computer, just like I said, based on ytterbium ions. So it's an ion trap quantum device. And so I'm happy to talk more about it, but that's by way of my introducing myself. We're also launching sort of the soft launch for this Open Quantum Design project that quite a few of us are involved in. So thank you.
You're welcome. Thank you, Roger. Very exciting. And it's nice and refreshing to have a theoretical physicist amongst us. It's another perspective that I think it will provide some value.
I don't know. Sometimes there's too many theorists in the room.
Oh no! Oh no! Not in my circle. So maybe I'm missing out. Dr. Bandic.
Thank you very much for having me. Good afternoon, everyone. My name is Zvonimir Bandic. I'm PhD in applied physics from Caltech and worked as an industrial physicist, manager, and executive for 20 years in computer architecture, storage, error correction codes for storage, and memories. And I'm also bringing my open source hardware experience into the org. I'm a co-founder of RISC-V and a founder and chairman emeritus of CHIPS Alliance, and have like a 10+ year experience in sort of this nascent field of open source hardware organizations that go beyond research and academia, have corporate partnerships and relationships, and create a common standardizations and implementation ground for companies that collaborate on common cause, which in this case seems very interesting, which is sort of a north part of the stack, compilers, transpilers, everything that needs to bring a Python code to a level of signals. So great to be here.
And last but not least, our critic of the afternoon, Will.
I'll live up to it. Yeah, my name's Will. So I'm an investor at Quantonation. We're an early stage venture fund investing in quantum and physics technologies. But in my career, I've been involved in a lot of quantum open source things. At my first job out of college, I was at Rigetti Computing, where I worked on a lot of some of the first programming open source quantum computers packages there. And then about 5 years ago, I started the Unitary Fund, which I run. And it's a nonprofit research institute. We started around microgrants, funding open technology development in the field around the world. We've given about 100 grants now. We also have an in-house team that works on some bigger sort of public goods in the space. So we do benchmarking and compiler work. And then we have a community of developers around the world who are interested in quantum technologies, and they get into it through open source. We run hackathons. We actually just a few days ago released our open source survey, which we've now done for a couple years. Basically, there's all sorts of things in this space that need to get built that academia is not set up to build, and venture is also not set up to build. And so we help plug those gaps. And one of those gaps is around open quantum hardware. We released a white paper a couple weeks ago surveying that space. We'll talk a lot more about this kind of stuff. And so I'm super excited about this particular project in the open quantum hardware space with everything that Roger and Z and Greg are doing in open quantum design. And so Unitary Fund is excited to be one of their founding partners. And we'll talk more about that as we get going.
Ladies and gentlemen, you heard it here first today. So let's just jump into the fun questions. Why is open source important to quantum technology? Does anybody want to take a stab at that first?
I can jump. Because this is really hard, I think is the fundamental reason. I think it wouldn't be correct to believe that anyone could build a whole quantum computer on their own with what they know in their own head. And so you need help from other people. You need help from other disciplines. You need help from engineers who didn't study quantum physics. You need help from programmers who haven't done quantum physics, since they switched to finance, or something like that. We can bring them back. Those are the kind of types of people we see in the open quantum software community at Unitary Fund. And so by making this technology more open, we can get more people involved to help us solve all the hard problems that are happening. And I think fundamentally that's key to make the technology happen faster. And it's also key to help it happen better, because those people are going to have ideas about how to use it to help the world in ways that, if we stuck in particular myopic circles, we wouldn't get. That's kind of how I summarize it. You guys can add more as well. Yeah.
So my 5 cents on the question, right? Like for any open source project, there are typically sort of two components to it. There is the ethics of the open source and ethics of sharing the knowledge with the rest of the, interested scientific research and corporate communities. That's a kind of one kind of pillar. The second pillar is that open source becomes very important ground for standardization efforts and for common efforts that many companies often end up doing separately. And this was a very, at one point in time in computer industry, it was very common to have hundreds of different compiler companies until eventually that world through Linux converged to LLVM and GCC. And similar things ought to happen in a quantum computing world where there's a lot of commonality opportunities for all quantum computing companies in general in the north part of the software stack, and then plenty of commonality opportunities in various verticals that have similarities in technologies like ion traps and neutral atoms, Josephson junction circuits, and so on and so forth. And a lot of this effort can and should be common and will create ideal ground for communication and future standardization efforts and effective use of resources, especially human resources.
Yeah, I totally agree with all that. And I think our goals, when launching open quantum design is to really bring a community of people together who want to contribute, different parts of the stack, different technologies, be part of the design, collaborate. So really a forum for, collaboration and, just, I guess, interdisciplinary, if you want, sort of, get-togethers and meetups and forums where we can all contribute to an open, kind of an open concept machine.
So the tides will raise all ships is where we're getting with this. That makes a lot of sense. So what are the ways that you are working on furthering open source in quantum technology?
Okay, so maybe I'll start with just the focus of Open Quantum Design's project. So we hope to open up, essentially under an Apache license, if you will, the entire stack right from, I brought the blade trap holder. So literally, we thought we lost it over lunch, guys. I found it. Greg had it. So we're literally opening up the design from the bare metal, which is this trap holder, the blades that go into it, the vacuum chamber designs, all of those CAD designs and everything will be opened, including all the FPGA control, the control stack, the APIs, all the software, as high as we basically care to go. So what we're contributing will be these designs of this quantum computer, which has been under, I guess, development and prototyping at, University of Waterloo, IQC, and Perimeter for, 6 or 7 or 8 years now. So we're basically contributing all of this, if you will, design IP that's in academia, into the organization, and through that organization out to you. So all of our members who want to, anyone who wants to become a member of Open Quantum Design will see those designs under development. And then after they're open through, the proper procedure under an Apache license, the entire world will be able to benefit from our open quantum computer. That's what we're doing.
I just want to tack on that. I just think this is really important. I think we all know from trying to replicate things from papers that describe what they did and what they built that there's a lot missing. And so this project is gonna go further than I think a lot of other ones has to actually make those scientific technologies available and open and replicable. So congrats on you guys. I'm really excited about it.
Well, one thing that's on my mind in building OQD is to sort of create an environment and create the plans for IP licensing agreements and CLA agreements and membership agreement that will actually allow fruitful open source collaboration, and that will attract many members to sort of contribute and work together on things that make sense. I think that's one component that's kind of quite important. It's not physics, but it's still important for the collaboration.
So maybe I should say a little bit about some of the other non-open quantum design stuff. There's broad classes of public goods that are very important in the space today. So there's standards, there's educational materials, there's just networking groups, social connections, this kind of stuff. One of the big areas that we're working on at Unitary Fund is compiling. And that's for the same reason that Z mentioned it. We have an open source compiler called Mythic, which works with pretty much any front end and back end. And it does error mitigation right now. As the intermediate representations in this space, which are themselves open, OpenChasm, QIR, start to standardize a bit more, I think we're going to see more development in compilers that will save a bunch of people a lot of time. Like right now, kind of every vendor, every SDK is inventing its own compilation passes, and compiling is only getting more complex. You want a system that's accretive. You don't want to have to be re-implementing the ideas for how to do gate optimization while you're also deciding how to compile into small error correcting codes, while you're also trying to do best-in-class error mitigation. If you have to rebuild that from scratch every time you have a new algorithm you want to implement, gosh, it's...
We'll totally nailed it on the head. The quantum industry needs to compete against the AI industry for a precious and limited resource of people who are knowledgeable in various compilation technologies, and there is not enough experts, on the planet to serve what's needed. And the only sort of path out is, figuring out what's reasonable to make common.
And another big area we're working on a lot at Unitary Fund is benchmarking. So we have a platform called Metric. It's metric.info with a Q, because we have to. And there you can do two things. You can post a new idea for a benchmark task for quantum technologies. It could be simulation, sensing. It could be like coherence gain in a quantum memory, which is maybe like a big one we're going to see more of. So you can post that task, and then you can post results against that task. And now there's a dashboard online that folks can track and watch as the field helps develop. If people want to add more benchmarks to that tool, talk to us. If you want to collaborate on running more benchmarks, we're happy to talk about that as well. And then broadly, there's all the other stuff. There's hackathons, surveys, all these things that we're trying to do to help the open community be more robust. So many companies have open source packages, but who's contributing to them? So if you're in that boat, come talk to us.
So you kind of touched on the next question, which is, what are current open source projects that are important to the ecosystem? So you mentioned benchmarking. Anything else that you guys want to add a little color to?
mean, I could turn, I won't turn it into a talk, but I'll just hit some highlights. So tools for resource estimation. I mentioned this morning if anyone was at the fireside chat. If we're going to need a lot of capital to get to where we're going, we need to convince people it's worth getting there and that we also know how far we have to go. And that's what resource estimation is about. It's a targeting exercise. We have some software, very mature software, for programming noisy quantum computers, and that's different than the software you want to do resource estimates for good quantum computers. There's a few tools there, but we need more. Now is the time to start thinking again about higher level quantum programming languages. Python is fun, but higher level quantum programming languages is not. And there aren't really that many. There's a few academic groups thinking in theory. There's the Q# ecosystem, there's Silk, there's a few little prototype things. We funded some at Unitary Fund. It's not a company per se as of yet, but there's important technology there. And then there's a whole bunch of software for doing the control and operating around error correction and mitigation together that are all coming. Maybe I'll just stop there, keep going. But like those I think are like three big software areas for open stuff where there's just really not that much as of yet.
Yeah, right. And we've already incorporated some open source tools into this stack. So the Arctic, basically FPGA control, which is provided by MLabs, is an open source control piece that is already integrated. So we hope that we're not just building our own open source tools or open source stack components. We're actually integrating hopefully a lot of the open source tools that are already out there into our computer. So.
Great. So what are the main gaps in the open source ecosystem today? I mean, if we're addressing some of these current projects, does that cover us, or is there anything else? Are there other gaps?
One of the gaps that I kind of see a lot of commonality with open source electronics and open source ASIC projects is access to the lowest level of the technology. So in the world of integrated circuits, the process development kits owned by foundries are very, very confidential to the foundries. And except for some effort Google has done with Skywater 180 nanometer PDK, there have been very little industry efforts to open that. Parallel in quantum computing is actually having researchers in academia gaining access to the lowest levels of the quantum computing, and that's one gap we will address. So participants in the OQD will actually have access to what are the signals that ion trap machine needs, what does FPGAs have to produce, how is that linked to the compiler and transpiler above it, and so on and so forth. So this kind of information will be available both to inspect, understand, and improve.
Yeah, it's certainly true. So the lowest level pulse control that will open up, it has to have a little bit of, there has to be some, I guess, boundaries to blowing up the thing with lasers. So there is a bit of, there is certain low level control that users won't have access to, but the lowest safe level of control we're actually developing APIs for. So when the machine is built, more technically inclined users will essentially be able to shape pulses directly, through the FPGA control into the trapped ion system. And then we'll have another 2 or 3 sets of APIs higher in the stack, depending on the expertise of the user, hopefully. So not only will the machine that we're building, the ion machine, be the design will be open, but the machine itself will eventually be opened up to users to access at all of these different levels. And so I think that's something unique we're hoping to provide.
So if you want to build it and turn the lasers up to 11, you really can. I just wanted to double down on what Z said. Like the foundry, the availability of different test foundries coming up is like Lincoln Labs, there's other ecosystems that are doing things. It's going to be a transformative thing, but I've talked to some ecosystems that are trying to set up that kind of access, but they want people to sign an NDA before they get access to even the PD kit, the process development kits. And that kind of barrier is not so great for an ecosystem that's pretty early, a lot of academics, hobbyists, early stage stuff. So I'm hoping that we can get a little bit of collective action together to make some of those foundry processes, at least in the very early stage for basic qubits, really, really open.
So we talked about what some of the main gaps are in open source, and you talked a little bit about how we're addressing them. Is it worth exploring the why those gaps were there? Or is that too philosophical for this conversation?
No, it's not philosophical. I think it's very natural in any kind of business to develop a proprietary IP that becomes the pillar of growing the profitable business around the company. But there's also a question of timing, and then there's also a question that of kind of universal human knowledge when it comes to new technologies like AI and quantum computing. So those things should remain in balance. But we are pretty much inclined to build OQD so that it is corporate friendly. And this has been done before in CHIPS Alliance. It has been done before in S5, where there is a very meaningful balance because there is a need for standardization and there is a need for sharing resources. Obviously, what will be open from the quantum development kit perspective will be the University of Waterloo quantum machine. It will not be machines from the participating companies. They obviously remain proprietary to them. But it's a very nice thing that everyone actually has a real machine as a target when they're exercising improvement in a compiler or some new technology, how to make the number of epochs smaller, etc. Or to develop error correction. Sorry, Roger. Yeah.
I was going to say another answer to that question is, I think one of our goals in building quantum computers is scale. We have a lot of academic groups like our own that are building these things in laboratories, but then how do you scale? It's an industry question, right? How did we scale the semiconductor manufacturing industry? And so I think just partially an answer, there is a gap between scaling in academia, which is difficult. You can get government grants and so on. You can spin out technology into startups, which then take venture capital, of course. But I think the question is there something else? Is there some other way of harnessing that intellectual property that we've developed and using it to fund the scaling of that machine? And I think open source, development is still widely unexplored. So just a partial answer to that.
A little bit of a gaps story, I guess I could say. So I think a lot of these gaps come from structural alignment and things. So one of the things I worked on early in my career was the open source software we built at Rigetti around Quill and PyQuil. And so we built and released this open source software package. And at the time I was like, this is great. Like we built this, we released it. Like other people are not going to have to build their own Python package for programming a quantum computer over an API in the cloud, right? And we had 5 years of people all building their own version of that. And why did that happen? Well, not because what we built was amazing, but it's also structural issues. People don't want to use some package that's developed by another vendor that they're competing with. And so you need to have places like Unitary Fund, like Open Quantum Design, like these more neutral grounds where people can put something and then others can contribute into it and know that it's going to be available and independent and not kind of competitively controlled. And it's taken a while for those institutions to develop, but I'm hoping that's more of the role that we can play going forward.
And this issue of NDAs that was brought up is, I think, also important in terms of the gap. One of the impeti, behind spinning OQD out of University of Waterloo was the other technical founders, Crystal Senko and Rajabul Islam, who are the ion trappers, essentially came to me and they're like, we would love to collaborate with you, the companies and the industries, the IonQs and the QEras and so on. But it's sort of a one-sided, how do we manage that? What's the structure within which we can build a collaboration that lasts, that has, value proposition going both ways and so on. And so I think that was really lacking before. So we hope that OQD will provide this forum for collaboration between the academic groups, between the large caps and also the SMEs.
One more comment, since Will inspired me mentioning actual compilers, right? In the computer industry 40 years ago, there has been hundreds of different compiler efforts. Almost one computer company would have its own compiler effort, typically drawing 50 to 100 people over a period of 2 or 3 years. And that really did not make sense. And 40 years forward, ended up having two compilers, both in open source with two different licensing models, which are actually the pillars that determine what is being used for what. There's a GCC compiler that remains a pillar of the Linux kernel, and the GPL licensing world, where everything that's being developed on top of a certain open source product has to be contributed back to that product. And then there is a LLVM compiler, which is more popular and more vibrant and more used. It was built on Apache v2 licensing model where large companies agree to collaborate in open source. And then after the agreement and a handshake, they actually work on this compiler together. And these are very often forked. So LLVM is common to many, top, hyperscale computer companies, and cloud companies, but very often they also get forked and they're used to implement proprietary extensions that are important for the very specific nature of their business. So we hope to be the latter.
So do you guys, so could you talk a little bit more about, you touched on this already, but how will this impact for-profit entities?
Okay, so I guess since I know the least about this, I'll start. I was very much inspired by Zvonimir's involvement in RISC-V, which is open, kind of instruction set architectures and standards, where there's an ecosystem of, I guess, for-profits that orbit around it. And you can imagine in the simplest model of how this works is for-profit companies build the computers that are based on the open design. So I think one aspiration, for OQD in the future could be this. It could be that we provide designs and for-profits take advantage of those designs and so on. But I also think there's a role for for-profits to play in helping us design our machine. You asked what's kind of one of the technical gaps. For us, it's really compilers. I need compilers. We need them now. We need compilers down from Hamiltonian level or gate level, basically designs down into the atomic pulse layer and so on. And I, through a lot of my friends who I've met through CDL and other places, know that there's a lot of companies out there that have tools, control tools, compiler tools that they've been thinking about open sourcing. Maybe they're not using it directly in their stack, but they were developed by their teams and so on. And so I think there's a lot of give and take that we could have with the for-profits in this collaboration.
I want to add something to that. So in my experience with standardization of the operating systems through Linux APIs, through standardization of various storage and storage networking interfaces, and then with standardization of the RISC-V instructor set architecture, all of the corresponding markets actually started growing more aggressively after those standardization efforts have been established because they created plug-and-play opportunities for much larger companies and growing ecosystems freely. So all these examples actually experienced a hockey growth curve after such standardization has been established. So seeking those common interfaces, I think, is very productive to profit generation.
Yeah, I guess like the way we often talk with our partners about it is open source is a way for you to source talent and hire, and a way for you to sell and develop customers. Like we've made a bunch of our partners have made hires from our community because the interview process consists of, I know you just contributed some great PRs to the software that's key to our business. Your job is to contribute PRs. I just saw you do it for 6 months. Like there's no better way to find great talent. And test them. And then on the other side, when you do the customer development, you go meet some Fortune 500 company that's thinking about quantum, and they know you're legit because they've been using your tools. They can just spin it up and try it themselves. Especially with something like quantum, where it can feel a little distant from being real. That kind of access is really, really helpful. So those are really two big areas that we focus with our partners on.
So I think the cheeky answer is I don't think an open source quantum computer is a threat to a for-profit quantum computer. And I hope that's true, but it's certainly not the intention of an open source quantum computer.
I would agree with that, but some folks might think I'm biased since I'm with the government.
Let's write that down somewhere. Said in 2023. No, I'm kidding.
So could open source be applied to quantum sensing or quantum communications, quantum security tools as well?
Yes.
Yes, and in particular in cybersecurity, open source is so critical because that's how people validate and test and make it open. It's the same kind of principle. So I'll just say double yes.
I'm glad to hear that.
Triple yes?
As a practicing experimental physicist, Of course, I think many of the quantum devices will obviously respond to, unfortunately, to external stimulus, and as such, they are sensors, and all the infrastructure in terms of the precise signal generation, compilation to analog signals, is and can be used for sensing almost unchanged.
Yeah, and I would add, it's not the initial intention of open quantum design to think about sensing and communication and so on. I think part of our goal is to remain focused. You know, we have an ion trap, we have a proven technology, it's been under development for years at IQC and so on. But that doesn't preclude, you know, the members of the open source community from steering the technical development in directions that, you know, we could all agree on as being fruitful, like sensing and like communication. So I think in an open community with open design forums, these decisions would be made by members.
Great. I have one more question, and then we'll try to open it up to the audience. How do you see open source and quantum technology evolving over the next 3 to 5 years?
Well, we will be huge. No, I'm just kidding. I mean, when we're thinking about open quantum design, I mean, we're only limited by our imagination, honestly. I think there's a lot of open source projects out there in the quantum world. My intention really is to anchor a lot of these projects around the ion trap design, the Ytterbium-171 ion trap design, and then just let it grow from there. And so I would hope that we could become a home for many different open source quantum projects that begin, you know, focused on our hardware, our full stack hardware that we're building up. But I would love to see this community expand, and I'd love to be back here in 5 years and count the entire audience as members of OQD.
Great. I think for themes, today there's already quite a bit of open source quantum software where people think about it, the applications and programming layer. That's going to deepen and become more important. And what we're going to see more emerge are open source efforts around the hardware. There are some that exist, but that's starting to happen because now there's just more consumers of that supply chain. People who actually care that, you know, a kick open source software control system is thousands and thousands of dollars per channel cheaper than what you can buy from Keysight. And they're willing to do the open source development to build that. So we're going to start to see many of those components start to come out and get more robust. Same thing with design software for superconducting quantum chips or spin qubit quantum chips. The open source on the hardware side is earlier, but over the next 3 to 5 years, I think is going to grow significantly.
I will add one thing. I think there are super smart people at this conference, like Professor Preskill, who can answer what will happen on a 7 to 15-year horizon. In terms of the interesting things that can happen in open source quantum hardware, like OQD, is having a full and complete access to the actual quantum machine, the ion trap machine, and having an ability to work on error correction codes as a community, and having an ability to, which is maybe even more important, to work on optical interfaces for putting more machines together, and working on traditional computer interfaces for enabling sort of work on a hybrid computing, a hybrid classical quantum computing.
And something we're really interested in at DOE is what would happen if we had a network of quantum sensors, and that could be a game changer for us in many different applications. So, okay, I would like to open it up to the audience. Any questions for our esteemed panel here while we have them?
Keep waving.
My background is semiconductor test, and I looked it up, and it's 20 years ago there was a attempt to do an open source semiconductor test system called OpenStar. And it sounded good on paper, and I had a small tester company that we participated in all the initial conferences and meetings and the spec writing. The one way that it did not work out, it ultimately was dominated by one of the biggest company called Advantest. And they contributed a lot. They did a lot of work, but ultimately it was impossible for anybody to add an instrument to their things because, you know, they shut the door. So I'd caution you to look out for the big guys, and the more smaller guys that participate and provide that IP, the better. So.
Of course, and you know, I've studied the history of computer architecture and computer interfaces standardization, and for every successful one, there's 9 failed ones, but usually those were heavily linked to one company. So prior RISC-V, there was a fantastic effort called, I think, OpenSpark that came from Sun Microsystems and Oracle, but struggled because it was dominated by one company, and contributions by member companies, even Fujitsu, were heavily limited. And there was no ecosystem where university partners or students can actually kind of contribute back. It was more like a one-time. But at that time, a lot of awesome CPUs were actually open sourced, and they were used, but slowly sort of faded away.
I think it's very helpful that
Yeah.
starting in the university, and that's
Absolutely, yeah. Yeah, universities start, and that's how RISC-V was done. RISC-V was done by an amazing amount of well done work that came from Berkeley.
We have 3 minutes left. Any other questions?
Well, I guess I'll just say one thing just for you guys, which is that it's starting in one university, but it could be in so many other ecosystems. You know, people are talking about quantum engineering PhD courses or master's courses. There should be a final project, build an IOT trap. Might go for a few years, but...
One experience that I have, which I think is really great for projects like this, it will allow student experimental labs at any university across North America, European Union, India, to basically have a lab classwork for quantum computing classes that can be based on a real system that they can have access to and possibility to modify it and improve it. So this is what we've done with RISC-V. 10 years ago, nobody knew about what this thing was. This year, any grad student or undergrad student that comes with a degree in computer architecture typically had a lab class that was done in RISC-V.
We have a question here.
Yes. So I was just wondering comparing it to the history with the semiconductor as well, the case of like Moses, right? And you know, what thoughts you have about that, like the fact that it's just expensive to make all these kind of, you know, prototype chips and things like that.
Moses was a long time ago. So when I started at Caltech, Moses started dying. So I entangled only like very, very little. So it's hard for me to comment. But more recent effort between, and this is easily Googleable or searchable, it's Google and a Skywater open sourcing of the PDK. And that has been very powerful, and a couple of startup companies actually enabled student projects and a multi-purpose wafer runs for very, very affordable. I think it was like $2,000 per actual silicon coupon, where students could produce real digital circuits open source from top to the bottom, right? Like they could publish the GDS2 layout of their chips. So.
Well, I'm going to date myself a little bit here. I'm not a hardware person, but I do remember the days when object-oriented programming was a thing, and the fact that we were able to do programming in this open source environment and build the e-commerce environment, it helped change the world and really accelerate the future. So I feel like this is another one of those opportunities here where we're creating an open source environment that will help drive innovation and allow people to tinker, and we can learn by doing. So very excited to hear what's up next and how this progresses. And with that, we've met our time. So thank you all, and thank you to this wonderful panel.